Maybe it's not written down. You have them in front of you. Did they come out on? Yeah. Okay, so I'm going to go to a new sheet of paper and write this down. So let me take this first function. F of x equals x squared minus 4 over x squared plus 7x minus 8. And my handwriting will get better. I've had 3 weeks off, and you know how that is, right? So what am I trying to do? Determine the domain algebraically. Trying to figure out what I can and cannot plug into this function, right? So what are the things I'm concerned about? The denominator can't be 0, right? So how am I going to figure out when this is 0? Probably try and factor it, right? Well, while we're factoring, we may as well factor the numerator also. Just to make sure that we're okay at factoring. What's the denominator factor to be? X minus 1 plus 8, is that what I heard? Okay. So now what I can do is I can take each of those factors, x minus 1. I can ask myself, when would that be 0? And x plus 8, when would that be 0? And that would be at 1 and what, negative 8? Okay, those are the two values of x that I cannot plug in. If I plug them in, I'm done, right? The function's going to not be able to handle it. So how do I say everything except those? How would I say that mathematically? There's several ways. There's set notation, interval notation. So you're saying all real numbers except equal with a line through? Is that what you're saying? I haven't seen that one. Okay. I'm not sure that would be as precise the notation we'd want. I know what you're trying to say. All real numbers except the set 1, negative 8. That would be proper. Because this says all real numbers take out these 2 points. Okay? Not equal. I understand what you're saying, but that's not the way we would do it, write it mathematically. Okay, that's one way to write it. You could say x just not equal to 1 or negative 8. You could say the set of x such that x is not 1, x is not negative 8, x is a real number. I mean, there's so many different ways to write this. This says all x such that, that's what that bar means, all x such that x cannot be 1, x cannot be negative 8, but x is a real number. But this is the way I prefer, okay? I like this. Number line. This isn't going to be my final answer, but here's number line, right? When we were doing positive, negative, increasing, decreasing, weren't we doing intervals? I think knowing how to write intervals is a more powerful thing. It's better for later on, so you may as well use them now. How could I say everything except just don't have that, don't have that. You can have everything there. You can have everything there and everything there. X must be an element of negative infinity to negative 8. Don't include negative 8, right? Union, negative 8 to 1. Don't include negative 8 or negative 1. Union, what? 1 to infinity. Do you see what happens here when I write it that way? It's basically everything. It's longer, definitely. But again, I think it's better for you as a student to get comfortable with intervals. All this does is jumps over the 2 points, right? It's like negative infinity all the way you get to negative 8, jump over negative 8, negative 8 to 1, jump over 1, 1 to infinity. Okay, that's the first one. Next problem was g of x. How long have we been going here? An hour and 15? Believe it or not, we've got to go like another 30 minutes before our first break. And we come back and basically do it again. Does that seem right? That doesn't seem right, does it? We're supposed to go for what, 3.5 hours? Is that what it is? So what's that, an hour 45 twice? Yeah. You signed up for it. I took Cal 1 in the summer. There's pros and cons to it. You don't have a lot of time to forget, but you also don't have a lot of time to swallow or breathe. All right, what about this one? What are the things we're concerned about here? Yeah, there's a couple of things, right? First of all, what's inside of this, right? What's in there, which we call the what? The thing under the square root is called the, anyone remember? Starts with an R. Radicand. Radicand. The radical is the symbol itself. The radicand. The radicand cannot be negative, right? The radicand can also not be what? 0, because what would happen if the radicand is 0? Square root of 0 would be 0, and then you get division by 0. Do y'all agree with that? So we have two issues here. So I'm going to write that down. What we have is this. 4x minus x squared has to be bigger than 0. Strictly bigger, doesn't it? Can't be 0, because I'll have division by 0. And it can't be negative, or else I have a negative under a root. Now, this is what's called a quadratic inequality. A quadratic inequality. And it's very different than a quadratic equation. Because if it's a quadratic equation, we could just try and factor it, set each factor to 0, we'd be done. Or you can always use quadratic formula for a quadratic equation. Quadratic inequalities are much trickier than quadratic equations. So here's my recommendation to you for a quadratic inequality. Either go Google it and look at some YouTube videos on how to do quadratic inequalities, because it's not part of this class, or just follow the method I'm going to show you here. First thing I'm going to do is I'm going to ask myself, when is it 0? So I'm going to turn it into an equation, but just for a moment, and I'm going to remember that I need to come back and look at this as an inequality. Where's that thing 0? Well, what can I do to solve this? Factor out an x, good. I'm left with 4 minus x, right? Set each factor to 0. I'm using something called the zero factor property. You've done it before, but maybe you don't remember what it was called. The zero factor property allows me to set those equal to 0. And now what are my two solutions? 0 and 4. X is 0, x is 4. Now, do I want those as my answers? What would happen if I plug in 0 or 4 according to this? I would get 0 to come out. And I don't want 0, do I, right? I wanted it to be bigger than 0. But why is this useful to me? Let's see. Because if I go to a number line now, and I say 0 here and 4 here, I don't want those as part of my answer, right? But geometrically, okay, geometrically, if I were to take this thing that I'm highlighting now in blue, see if that blue comes out okay. That thing right there, forget the greater than 0. If I told you, hey, that's a function, what kind of function is it? Like when you graphed it, what would it be? Is it a line? What is it? It's curved. What kind? It's a special category of function. It's a parabola, right? Why? Because it's x squared. Which way does that parabola open? Down. Why down? Because I have a negative in front of the x squared. So this is a parabola that opens down, doesn't it? Further, I know that it hits the x-axis where? 0 and 4. So if I came in here right now, let me do this in green. I could actually tell you that my parabola looks like this, doesn't it? And what is it that I want to know about this parabola? When is it what? Bigger than 0? That means when is the function positive, right? Can you tell from this little picture I drew? Between where and where? Between 0 and 4. You see that? Without doing, I mean, I had to know what a parabola looks like, and it opened down. But I'm kind of like using my knowledge of parabolas to answer this domain question. So what would my final answer be? Everything between 0 and 4, but not including 0 and 4. So x must be an element of parentheses 0, comma 4. Done. What if I didn't know what that looked like? Well, that would be a whole different animal, okay? But quadratic inequalities, you can always do this way. If you kind of know what it looks like, you can do it like this. Once you get past quadratic inequalities, you get to like cubic or fourth degree or something like that, then you have to have a little better method, and that's where I would suggest you go look it up. I don't think we're going to run into it, but you've got this great resource called the internet, which I don't think I had that. Well, it was around when I was a student. It just wasn't what it is now. All right, last one. Hey, secant, check it out. Didn't we do that one a little while ago? That was totally unintentional. H of x equals secant x, which we already said was 1 over cosine x. And we had already said earlier in class that we basically said cosine x can't be 0. And we had said that, okay, that could be what? X is 90 degrees or 270. That's where that happens? Yes? Okay, this is extremely important, but it's tricky. So this is where your pre-cal, which all of you passed to be here at some point, right? This is where I'm going to see how many of you know the unit circle well enough. That's a terrible unit circle, but that is a unit circle. How many of you can read trig values off the unit circle? Raise your hand. Like if I ask you what's sine of 30 degrees, if you had the unit circle in front of you, you could tell me. Raise your hands. That's it? Okay. Then I suggest that you put that as a note for yourself to get help with or come to me before class. It would only take about 10 minutes to show you how to read trig functions off a unit circle. But it's vital that you can do that in this class. And you want to get to a point where you don't even need it in front of you, where you kind of just see the unit circle in your head, and you can do it. So we said earlier that the two places on the unit circle where you get cosine to be 0 is up here and down here. And that's because what are those points? This first one's 0, 1, and this other one is 0, negative 1, right? And cosine is always the x-coordinate. So what angle is this? We said the angle was 90, and then the other angle was 270. But that's only 2 of the answers. There's actually infinitely many answers. So how could I say all of those answers? Because I could keep rotating around, right? Keep on going around. Well, there's some things I can plug in. There's just those I can't. Let me help guide you. Do you agree with this? X cannot be pi over 2. Do you agree with that? Because if it's pi over 2, we're pointed straight up, and cosine of that is 0. Now, if I go and I spin around halfway, That's still no good, right? And if I spin around another half, it's still no good. And if I spin around another half, it's still no good. So if I add something over here, watch this, my pi over 2. What if I say plus